The life of human beings is closely bound up with their circumstances. With science and technology advances, we have been well accustomed to using computer systems to obtain the latest weather information, search for a recommended restaurant, describe the current position, or even plan travel route prior to selection of a destination, which we can reach smoothly by access to spatial information even if it is unfamiliar to us. Nowadays, convenient portable devices and ubiquitous internet can offer easy access to all the content that was gathered in books, magazines, and maps previously, and display them in an integrated way, thus improving the quality of our life significantly. We have to own such conveniences to technological developments of Geographic Information System (GIS) over the past 30 years. GIS involved the theories and technology to collect, manage, process, analyze, distribute, and apply digital spatial data with computers. To put it simply, phenomena in the real world are stored and integrated into a computer system in the format of digital spatial information, and convenient tools are developed so that users can understand conditions of the real world for optimal decision-making through the system interface. For users, the richer GIS contents are, the more services it will provide. For example, remote sensing images may display the overall condition of a local area. By overlaying land use data onto remote sensing images, we can analyze the relationship between land use and its corresponding situations in real world. By further adding school data, we can evaluate the neighboring environments near the schools. GIS can be easily integrated with data from different fields to generate new information in response to various needs and creates various applications to enrich our life. In present days, application software (app) in our mobile phones often acquires different information from others through connection and develops value-added function. For instance, a map overlaid of the rainfall data from the Meteorological Bureau will present the condition of the rainfall in various areas. As long as related resources are available, apps can be developed in response to specific requirements, and users may gain access to abundant functions with several simple operations. Therefore, needs for spatial data are also increasing. Due to the progress in digitalization, the volumes of data in various fields are accumulating quickly at an unprecedented speed. According to statistics, the volume of data doubles every year, and it is estimated that 80% of them are geographic related. How to take full advantages of the available data for a better future will be a challenge that confronts us. Sharing is a common behavior in the internet world, and we can obtain the shared information from the others and use it into our own apps. The greatest advantage of sharing is that we can fulfill our tasks and decisions more quickly without repeating the same work. The information from experts has higher credibility and helps to make up for users' lack of perceptions. For example, when there are many restaurants in an area, but we want to find a better one, we may go to search websites and browse the food and beverage service information shared by the food experts, so as to reduce the possibility of making mistakes in selections. In the future, we will be confronted not only with the environment where data volumes increase quickly, but also with the challenge of utilizing the resources available properly. Similar to sharing of food information, application of digital spatial information also faces the same challenge. When we need spatial data, if professional units can continuously provide various kinds of spatial data which are credible enough, it will be extremely helpful to users' decision. The acquisition and the production of geospatial data is not an easy task. It not only requires high professional skills, but also demands a lot of investments. If the data must be updated continuously, the cost will be considerable. To realize such shared environments, careful planning and reliable mechanisms are necessary to meet the needs of all participants for application. The concept of Spatial Data Infrastructure (SDI) is to promote sharing, integration, and application of digital spatial resources among various producers from policy, standard, and technological perspectives. In a simple word, different types of spatial resources come from different units, but they may be integrated effectively through SDI development, so that users can easily obtain and apply the shared resources. Through detailed analysis of the scope is set, SDI assigns proper tasks to the concerned participant and serves as a bridge between resource providers and users for mutual exchange and better sharing. SDI may be classified on the basis of the scope for sharing. It is referred to as National Spatial Data Infrastructure (NSDI) if it is shared by a nation under its scope, and will be known as Regional Spatial Data Infrastructure (RSDI) when it is shared by a region, such as European Union's INSPIRE, which is a mechanism for spatial resource sharing among the EU member states. If SDI is accessible to the globe, it will be referred to Global Spatial Data Infrastructure (GSDI), and currently, the GSDI Association has been established to promote affairs related to geospatial information sharing in the globe. Similar to experiences in using GIS, users certainly expect to use the spatial resources that are scattered in different places in the SDI context. The considerations include, first, diversification of data to meet the needs of users from different fields. Second, accuracy of data, since inaccurate data will lead to wrong decisions and result in irrevocable effects. Third, timeliness of data, as many applications must respond to quick changes, and inability to get the information on the real world in a timely manner will have a negative impact on decision making. Diversification, accuracy, and timeliness are the important considerations for SDI in promoting resource sharing among different fields. Since data come from different providers in different formats and designs, proper and integrated application poses a big challenge, and we must rely on development of standards and technology to remove the barriers against data distribution. For example, when we want to replace a battery in an electric device, no matter who manufactures the battery, it can be installed for sure as long as it is of the same model. Even if the maker of the electric device has nothing to do with the battery manufacturer, installation is never a problem, chiefly because design and production of the electric device and battery must comply with the battery size standards. If there is no standard, we may have to spend a lot of time in looking for a battery of proper specifications. Obviously, formulation of standards makes technological developments in all relevant fields become purer and simpler. International travel is often accompanied by photographing and shopping. We all know that we must first inquire about the specifications of the socket by the country to which we will travel, in case we cannot recharge camera batteries. This is because socket specifications are not standardized in different countries, and we must get different plugs to correspond to different socket specifications. Compared to it, we are not worried about using credit cards in foreign swipe machines. because our credit cards are made according to the same international standard. As long as shops are willing to accept credit cards, nowhere may we have any problem in swiping credit cards. Standards allows overall development to be promoted towards a uniform structure, and avoid the cases where everyone acts in his own way without mutual communication. Application of standards is seen everywhere in information field. For example, we can use the browser of any company to open HTML-based web pages developed by different units. Even though there's no substantial relation between the web page designer, web publishing software developer, browser software developer, and users. This is because HTML is a commonly accepted technical standard, and operations can be fulfilled successfully as long as different role-playing members complete their work according to their assignments in the application. Formulation of HTML standards allows members to communicate with each other without contact. Instead, the structures that do not comply with standards often require users to adopt specific software, thus creating barriers against sharing an application inevitably. The rapid growth of GIS market is supported by various data formats and software technology from different GIS vendors. Though the use of single GIS software is often easy, problems may occur when heterogeneous data from different resources are integrated in users' applications. For example, data cannot be opened, contents cannot be read, or data requires special processing, etc. All this presents an obstacle to promotion of SDI. ISO TC211 and the Open Geospatial Consortium began to work on technical formulation and development of geographic information standards since 1994. ISO establishes the ISO 19100 series of geographic information standards, which are widely accepted by countries in the world as a common standard for NSDI. As a civic organization supported by industry, organizations, and academic units, OGC focuses on development of software technology and standard documents, and devotes itself to practical applications and technical specifications. The key to GIS technologies developed by ISO TC211 and OGC is openness. Unlike past software development that highlights self-formulated formats with difficulty in interpretation by other software, open structures record data in an open structure like XML and meets the needs for communication among different application systems through services. These two developments make it unnecessary to use specific commercial software as a channel of distribution between providers and users anymore. A removal of the threshold for using specific software helps promote distribution and application of different data. Suppose that the provider and user utilizes software A and software B respectively. The user has to evaluate if software B can read the format of software A correctly. If not, software B cannot utilize the data of software A. In urgent cases, data conversion is required, and we must ensure that all contents can be converted correctly. For the open approach, data must be converted to open data formats according to the selected standards. Software B can read data correctly as long as it supports the selected standard. If there are other software C and D, it is not necessary for data providers to conduct any additional operations. As long as the software all support the selected standard, the distributed data can be easily distributed and used. A new structure of data distribution and integrated application is built on the basis of this standardization concept. similar to transfer of web contents via HTML. The strategy of SDI is resource providers distribute data and service in standardized ways, and users access desired geospatial resources also in standardized way. As technical standards have been issued by ISO, TC211 and OGC. These standards may be followed in data production and software development to build an easier model of distribution and application. WMS, WFS, GML, and KML are all technical standards developed on the basis of this concept. After geospatial data are distributed with standard techniques, whether users can interpret the acquired data correctly is certainly an important consideration. The open structure and contents of distributed data following data standards or specifications serve as a bridge of communication between providers and users. For similar data, even though they come from different providers, users still can interpret them only by following the above data standards, and users can integrate and apply all data correctly as long as they understand data standards in all fields. A big challenge in promoting SDI is to gain access to geospatial resources scattered in human resource market. It's like roles of job seekers and firms in human resource markets. Job seekers must provide resumes of their own, while firms can go over and check resumes of all job seekers to select the most appropriate candidates. Similarly, all geospatial resources are required to give metadata that serve as resumes of the geospatial resources to describe their features under standardized items. In this way, SDI resources can be completely controlled and supplied to users for inquiry and check. In Taiwan, the government-supported NSDI National Geographic Information System began to establish its standardization framework based on ISO TC211 and OGC standards in 2004. As of 2012, 20 data standards have been approved to facilitate the sharing of geospatial resources among different units using OpenGIS technology. Users can thus enjoy the convenience for easily accessing and integrating desired geospatial data for their domain-specific applications. To help users to search and understand the available georesources in NGIS, a nation-level metadata profile, Taiwan Spatial Metadata Profile, was also developed. Compliant with the ISO 19115 metadata standard, TWSMP provides a standardized way for recording and encoding metadata. Metadata established by various domains are then collected and managed by a common gateway system. A nation-level geospatial data sharing mechanism, Taiwan Geospatial Portal (TGOS), is developed to enable users to easily specify constraints and search for georesources that meet their particular application demand. SDI is an important step towards sharing and integrated application of geospatial data in different fields. Its successful operations are challenged by many obstacles. For example, different commercial software formats, different software technologies, partnership among various organizations, etc. Challenges at administrative, technical, and data levels require a new thinking on the roles and responsibilities of all participating members from an SDI perspective. Standard techniques establish a mechanism that is neutral to commercial software and widely applicable to various kinds of members. And this advantage can be utilized properly to promote distribution and integrated application of different data. However, all members must work together and give a bias to give full play to the GIS benefits and achieve the objectives for SDI.